Timeless concepts from Physics Helpline. In this video tutorial, we will discuss an integer type question taken from JEE Main exam of 2023. The question is based on the rolling of a solid cylinder without slipping down an inclined plane. Read the question carefully. A solid cylinder is released from rest from the top of an inclined plane of inclination 30 degrees and length 60 centimeters. If the cylinder rolls without slipping, its speed upon reaching the bottom of the inclined plane is dash meters per second, given g is equal to 10 meters per second square. We are required to fill in the blank with an integer. Now for this solution, the vertices of the triangle are not named in the question. We have done it for better understanding. It is given that AC, length of the inclined plane, is equal to L is equal to 60 centimeter, and angle ACB is equal to 30 degrees. Therefore, AB, height of the inclined plane, will be equal to L into sine 30. Putting the values, we get L is equal to 60 into sine 30 is equal to half, which is equal to 30 centimeters, which can be written as, converting into SI units, 30 into 10 to the power minus 2 meters. Let us remove everything and put it there. Now we'll discuss the related concepts to solve this problem. Here we'll be using the principle of conservation of mechanical energy of the cylinder between the points A and C. At A, it begins to move, therefore it doesn't have any kinetic energy, it has got only potential energy. Therefore we can write EA is equal to mgh, where m is the mass of the cylinder and g and h already known to us. What is the total energy at C? EC. Now obviously it is the bottom of the inclined plane, therefore it doesn't have any potential energy of the cylinder is equal to 0, therefore it has got only kinetic energy of both kinds, that is kinetic energy of translation and kinetic energy of rotation. So we can write EC is equal to half mv square plus half I omega square, where I is the moment of inertia of the cylinder and omega its angular velocity, and b is its linear velocity. This v and omega are respectively the linear and angular velocities at point C of the cylinder. Now I is equal to mk square and omega is equal to v by r, where k is the radius of gyration of the cylinder and v and r were known to us. Putting the values here, we get half mv square plus half I is mk square into v square by r square. Now equating total energy at A and C, we get mgh is equal to this one, half mv square plus half mk square v square by r square. Now multiplying throughout the equation by 2 and dividing it by m, we get 2 GH is equal to half m goes, so V square plus K square by R square into V square. K square by R square into V square, which can also be written as B square into 1 plus K square by R square, which can be written as V square is equal to 2GH divided by 1 plus K square by R square, or we can write V is equal to root over 2GH by 1 plus K square by R square. Let us remove everything else and put it there. Now for a cylinder, moment of inertia is given by I is equal to half mr square. Now comparing these two, we get K square by R square is equal to 1 by 2. K square by R square is equal to 1 by 2. Now we'll put the values here. 2 into G is equal to 10 into H is equal to 30 into 10 to the power minus 2 divided by 1 plus K square by R square is equal to half. Now one can easily see that there are two zeros and 10 to the power minus 2 gets cancelled. We got 3 into 2 is equal to 6 divided by 1 plus 1 by 2 is equal to 3 by 2 whole root over. This on simplification gives root over 4, which is equal to 2 meters per second. So V is equal to 2 meters per second. Therefore, which is the answer to the question. Therefore, we need to fill in this blank with the integer 2. This completes the answer to the question. Thanks for watching.